Because we have all of these plates moving around, this leads to all sorts of interesting interactions. And so this leads to both the creation and the destruction of the lithosphere at these plate boundaries. This will also lead to earthquakes, volcanoes, also create mountains along plate boundaries, and also we can find evidence of past plate boundaries because of these same features. And so there are three different ways that, three different types of boundaries. There's divergent plate boundaries. So to diverge means to separate or to split apart. So these are regions where the plates are splitting apart. There are convergent plate boundaries. This is to converge means to come together. So the two plates are coming into each other. And last is transform fault. A transform fault is a slipping or sliding fault. It's not coming together or apart, they slide past each other. So that is transform. Both the divergent and convergent will lead to the generation of magma, but we will not get the formation of magma from the transform fault. So starting with the divergent plate, again, divergent plates are where they spread away from each other. So we're going to find these predominantly along the mid-ocean ridges. So as the plates move apart, new asthenosphere is able to rise up and partially melt because of the decrease in pressure to form lava. This will then solidify, creating new lithosphere. So we actually form new crust as the lava fills in the gaps along these divergent plate boundaries. So this is again happening along the mid-ocean ridge. Now it is possible for a divergent boundary to begin to form within a continent. As this happens, it is going to break the thick continental crust at first, creating this deep valley, which is known as a rift valley. During this time, it is also likely that there will be shallow earthquakes. Now, over time, this valley is going to get wider and wider. It is also going to be volcanically active, so we might also be producing volcanoes during this time, until it is wide enough that it becomes flooded, and then it will turn into a mid-ocean ridge. So it begins as a valley in the continental crust, and then over time, the divergent plate boundary will transition into a mid-ocean ridge in the oceanic crust. Here's our fourth lecture quiz question. Which will sink? A, something less dense than the surrounding material, B, something more dense than the surrounding material, or C, something at the same density than the surrounding material? Go ahead and think about it, and we'll discuss it in just a second. So the answer is, if you remember back when we talked about buoyancy and densities, it is B. Something that is more dense will sink. Things that are less dense rise up. Things that are more dense sink down. So when looking at a convergent plate boundary, so again, this is where the two plates come together. If we have one of them that is more dense, it is going to sink below the one that is less dense. So we have the plates move together. Generally, the oceanic crust is going to be destroyed. Oceanic crust is made of basalt, which has a higher density than continental crust. The continental crust, which is less dense, is going to be deformed, and this motion is going to lead to deep earthquakes. Earthquakes happening deep in the Earth's crust or mantle. So we have different ways that the boundaries can happen. There's oceanic. This is where we have two oceanic crusts that are going to converge. Now, whichever of these crusts is older and therefore colder and denser is going to be the one that gets pushed underneath. This motion where one is pushed underneath, this is subduction. So the older, denser gets subducted. This leads to friction, and also this oceanic crust is going to have a higher amount of water trapped in the rock. This will lead to partial melting, which then leads to the formation of volcanoes. But these volcanoes are going to happen along an arc on the other side of where the two plates are coming together. Okay, so we form these volcanic island arcs. Some examples of these are Japan, the Aleutian Islands, and the Tonga Islands. We can also have oceanic continental convergence. This is where we have an oceanic plate crash into a continental plate. The oceanic crust is always going to be denser, so it's going to be the one to subduct. But again, this was going to lead to friction and partial melting, which will then lead to the formation of volcanoes along the continent. This will also lead to mountain building events as the continental crust is being compressed. So we actually get the formation of mountains and volcanoes in this process. A great example of this is the Andes Mountains in America, not South Africa, in South America along Chile. About 1 out of every 5 to 10 mountains in that range were actually volcanic, produced through volcanic action, as the oceanic crust is being subducted underneath the continental crust. Our last possibility is continental-continental. In this case, the two continents are going to have roughly the same density, which means we're not really going to have one being pushed underneath the other. Instead, we get this crumpling effect where the two crush together. As that happens, it's going to lead to the continental crust getting thicker. So we get taller mountain ranges, but also deeper mountain roots as the two crash together. This is exactly what is currently happening with the Himalayas. So the Himalayas are notable because they are the tallest mountains in the world. This is where Mount Everest is located. So what happened to form the Himalayas? We have the India plate that has crashed into the Eurasia plate. So the India plate at first had some oceanic crust, but eventually that got subducted until the India continent pressed up into the Eurasia continent. And as that happens, it leads to this crumpling into these large mountain building events. So these have the deepest and strongest earthquakes on Earth. Our last type of boundary are the transform fault boundaries. Again, this is caused by sliding. So divergent is where they split apart, convergent is where they come together, transform is where they slide. A lot of transform faults actually happen along the mid-ocean ridges. We'll see these places where the ridge suddenly jumps from one side to the other, where we get this sudden transition. Well, along that transition, we're going to be getting a transform fault. Some of the crust is going to be moving one direction, some of the crust is moving the other direction, so along that middle portion, we actually get a transform fault. So these often lead to shallow but very strong earthquakes. Now, it's not just along mid-ocean ridges that we get transform faults. The go-to example for transform faults is actually the San Andreas Fault along California. So in this case, we have the Juan de Fuca plate, which is sliding against the North America plate. And this leads to the San Andreas Fault. We can actually use earthquakes to help us kind of trace out the continental edges, the plates of these edges. And we actually find that most earthquakes occur along the edge of the Pacific Ocean. This region is sometimes referred to as the Ring of Fire because we have a lot of earthquakes as well as a lot of subduction and therefore a lot of volcanoes. So we get this ring of fire surrounding the Pacific with lots and lots of volcanoes. Earthquakes often occur where we have the boundaries between two plates. So this leads to a strain of the lithosphere, which is only able to go for so far until it suddenly snaps. Once it snaps, this releases a whole bunch of energy and leads to an earthquake. Here is our last question. Which boundary does not produce new lithosphere? A, convergent, B, divergent, C, transform fault, or D, all produce new lithosphere? Go ahead and think about it, and we'll discuss it in just a little bit. All right, what do you think? In my opinion, this one's a little bit tricky. Okay, so it seems, I hope that you can all agree that convergent is going to produce, or sorry, divergent is going to produce new lithosphere. As the two plates split up, magma comes up and creates new crust. Okay, convergent also is going to produce new lithosphere. Okay, again, that seems a little bit weird because with convergent we get subduction. Okay, one plate is actually being destroyed, but as that happens, it creates volcanoes, which are then going to produce more magma that actually creates new lithosphere. So convergent does actually create new lithosphere, just not as fast as the lithosphere is being destroyed. Okay, so our answer is actually C. Transform faults do not create new lithosphere. This is regions where we get sliding, but we do not actually produce magma or lava, which means there's no new creation of lithosphere. So the correct answer for this one is C, transform faults.